At the base of inquiry, whether it's science inquiry by children or science inquiry by grown-ups, is this human element of curiosity, a desire to know. And it's indicated by questions. And the question, whether it's asked by an adult or a child, is indicative of interest, being interested in something. And humans do this, children do this, adults do this all the time. When our focus is nature and we adopt a certain stance or attitude about answering our questions, then we're approaching science inquiry. And interestingly enough, this is the kind of thing that children engaged in almost spontaneously in their own play. Exploration is very, very important. Just exploring to see what will happen if I do this, to see what happens if I do that and do that. The reflection can come later sometimes. The way humans engage in activities when they are young, we call them play, but we also should just say they are play-like. We do this when we're grown-ups. I mean, in a science lab, people play with ideas to find out what will happen. It's serious stuff. And when the child is learning directly from materials, it is serious stuff. It is not wasted time. It is investment. You want to start with the children's experiences, where they are, what they know, and have them make sense of that. And then begin to encourage them to tease apart the components of that experience. And it's when they tease apart the components of that experience that they can begin to see the details and what the experience actually means. It is in the details, in looking at the details of the experiences, that they begin to see the elements of what they need to consider. And from those details and elements, then they can bring and begin to grasp scientific ideas. When we're allowing children to have these play-like activities and all of this tinkering, we are helping them to build a bank from which to draw as they try to figure out and understand and make sense of the world. The issue in science inquiry is, what do you do to get an answer to that question? Do you ask someone who you think might know? Do you go to a book? Or do you actually look for the answer in the phenomenon you're talking about? I think the first impulse is to ask the material itself. We want an accurate answer. So where can we get an accurate answer? We'll get an accurate answer by asking the phenomenon itself. And I know, for example, in some classes in Tanzania, in Africa, one teacher was doing something like that and told the children, ask the phenomenon itself, ask the material. And one child said, it doesn't speak my language. And the teacher said, then you know what? You have to learn its language. And that's when we begin to talk about children learning the language of the phenomenon, how to talk to it, how to ask it questions, how to understand the answers the material gives you. That is essentially what happens in science inquiry, whether you are a child engaged in it or you are a grown-up engaged in it. The thing about having children actually interact and investigate nature and phenomena of nature is that they build this rich repertoire of observations and questions and understandings while they are working with the materials. The children are building a kind of library or a data bank or encyclopedia of experiences on which they can then later draw when they are faced with a question. Understanding is acquired and not taught. You can teach for understanding. You can teach for conceptualization. But if you teach concepts directly, you are converting them into facts rather than concepts.